Hello, and thank you for joining us today for Frost and Sullivan's latest webinar from our Visionary Science Practice. Today's event is titled A Visionary Perspective of the Impact of Digital Transformation on the Global Agricultural and Nutrition Industry. My name is Anna, and I oversee Frost and Sullivan's Growth, Innovation, and Leadership briefings. Before we begin, I'd like to go over a few notes. We will have some detailed slides on this presentation, so there is a full screen feature available in the lower right-hand corner of your webinar player. You can safely share this briefing at any time via social media, email, or blogs. Today's discussion will also be available on demand shortly after we finished. And don't forget to submit your questions throughout the session today. Our presenter is Christopher Shanahan, Global Director of Agricultural and Nutrition here at Frost & Sullivan. Christopher has over 10 years experience in advanced data analysis, futurism, project management, consulting, and market research engineering, among other industries, as bio can be viewed on your screen at this time. With that, I would now like to hand the presentation over to Christopher. Please begin.
Thank you, Anna. Good morning, everyone, and good afternoon for those joining on east of me. My name is Christopher Shanahan, and I'm Global Director of our Visionary Science Team's Agriculture Nutrition Research Practice. And today I'd like to present some of our most recent findings from our study on the Internet of Things for agriculture nutrition market applications. It's a very I would say it's a very interesting and innovative deliverable that our company has developed, and definitely acknowledges the convergence between information technology, the needs of farmers, and other technologies, both physical, mechanical, chemical, biological, converging to address the pressing needs of the industry today. So first we'll go over a brief overview of the market quantifications, and then we'll dive into the key industry challenges that are facing the key industry participants along the entire value chain from farm to fork. And then we'll take a few minutes to look specifically at different levels of the value chain, different nodes of the value chain. First, we'll look at precision agriculture technologies and current trends in smart ag. Then we'll look specifically at the needs of processing, food and beverage processing, and then the future, with a specific focus on personalized nutrition and nutrigenomics as well. Yes, over the last couple of years, we spent a number of hours quantifying the demand for the industrial Internet of Things within the entire value chain from farm to fork, as stated. And we're calling this market segment, this opportunity space, the IoT for ag and nutrition market. In 2017, we quantified this market at nearly $18 billion globally. Includes both or all the various components of IoT, hardware, software, and platforms, and networking. And globally, this market is growing at a compound annual growth rate we're expecting at 9.2%. So it's increasing at a constant rate. We're at the mid-level in terms of the adoption curve as well. So we're seeing constant growth during this period in the growth stage. In terms of industry participants, I mean, we're counting each and every company that operates in this marketplace who are potential users of IoT, and it includes farmers, processors, logistics companies, and retailers, and of course all the variants within each of those categories. Across the entire value chain, the need is strong and growing every day, especially with the emergence of new demands, new markets, and in emerging countries, emerging economies, also with more sophisticated end users demanding faster, quicker, more convenient delivery of their food and beverage products, and that cascades back all the way up to the value chain, those same strengths and needs. And then, of course, the hazards that are present in the entire value chain, whether it's food safety hazards or other types of issues in terms of causing the system not to operate, and we'll talk more about that. How critical it is to ensure and maintain a fully traceable, transparent, and optimal system is only growing every day, and therefore driving the demand for digital technologies. I already mentioned, some of the key drivers, key factors that we'll allude to throughout this presentation is definitely the growing awareness for the need for improved food safety. Every week, the number of food breaches grows. Maybe it's a consequence of better information, better journalism, better reporting of breaches in food safety, but nonetheless, consumers are aware of this and demanding that their food is cleaner, safer, and also, all the while ensuring that it tastes good and nutritious at the same time. All of this will require innovative technologies to get us over the top in terms of improving food safety and traceability in this market. Also, the world, despite some of the the barriers that are, prevalent today, especially within the last few years, there still is increasing trade, global trade, and the movement of food and beverage products across the world. And the need for harmonized solutions, whether it comes from government or whether it comes from industry, is required to ensure that the system is operating efficiently, making sure that there's minimal food waste, that the food is going to where it's needed most, and no waste in terms of over inventories, spoilage, leakages in the system, et cetera. So all of that requires a degree of harmonization, which IoT brings to the table. And then, of course, I think, and this alludes to process manufacturing in general, but food and beverage manufacturing and agriculture and nutrition in general is a conservative industry sector. So there is some continued need for building the awareness of the benefits of IoT solutions in specific operations within the value chain. And we've seen this especially true in precision agriculture technologies and less so in other areas, but still prevalent across the entire system. But before we get into that, I just want to talk about some of the I wouldn't say cool, but some of the interesting things that have occurred over the last year that is either driving the need for better IoT solutions in agriculture and nutrition applications, or good examples of companies and organizations using IoT in this space. And I present this one. Clearly, this is a vendor who probably does not have an IoT solution, because they would have been able to prevent this event from occurring. As you can see here, this gentleman is delivering unpackaged meat through the front door of a grocery store, most likely an unsanitary vehicle, shopping cart. Now, clearly, pictures and people saw this, and it caused significant liability issues for the company, the delivery company, the meat processor who delivered this. Of course, having a IoT solution to ensure, such as a sensor that is on the pack or on the container, would have prevented this from occurring. So clearly, despite the availability and the awareness, this is evidence that there is still an unmet need for awareness of the true benefits of IoT. But a lot of other folks have gotten it as well. Here's another interesting bit from the news. This is from January in 2017, but it's still present today. Banana Coin. It's a real thing. It's a Ethereum currency, blockchain-based currency that's based on the available stock of bananas. specifically Cavendish variety of bananas, and which are the bananas that most people eat and buy at the grocery store. The standard commodity product that is grown throughout the tropics. The Banana Coin has identified a key situation, especially for those interested in speculation, that they understand that the banana is actually at risk from Panama disease. It's a disease that is threatening this specific variety of Cavendish, and it has the potential of eliminating the entire species of this specific banana, which would have a significant impact on the cost on available supply. So clearly, speculators who are betting that the disease will win in the end will definitely reap rewards from this. And then the Banana Coin folks who actually say that you can trade in your coin for an actual kilogram of bananas if you so desire. So it's even. So I think what's interesting here is that what's different from this versus other Ethereum currencies is this is actually backed by a real commodity and could easily be replicated with other food or agricultural commodities that are at risk of a significant supply issue in the future, and could be a great opportunity. Of course, when we go downstream, and apologize for not forwarding the slides, of course, probably what most people are aware of today is the impact of Amazon in the entire value chain. In the United States, they've acquired Whole Foods, which is an organic, natural, national grocery store. And it was their first step in establishing a true food and beverage and consumer good brick and mortar footprint throughout the entire country. But they're not stopping there. They're actually developing Amazon Go stores. There is some beta stores in Seattle, and others are opening in other parts of the country, which basically relies on cameras and sensors and Prime subscribers to basically have a cashier-less grocery store. Consumers walk in, they scan their app, much like the Starbucks app that many of you on the call have. You walk in the store, you pick your goods out, you put it in your basket. The cameras, the sensors knows who is picking up what products when, and you pass by the door, and then your Prime account is automatically updated, and you're charged. Eliminating people from this, removes the bottlenecks of cashier lines. It is being positioned in as a kind of for luncheon alternatives in big cities or as convenience stores. So definitely what's great about this is that Amazon understands the power of IoT to solve a critical situation, and that's bottlenecks, in the retail experience. And that's essentially what IoT does for all industry participants in the value chain. That is removing those bottlenecks and ensuring efficient flow of goods, money, and information. And then finally, probably another common use and similar use among food processors is the application of IoT for optimal and optimized processing. Before and for centuries, no one sausage was alike, even by producers as big as Tyson, the largest meat producer in the world, and chicken producer in the world. Every sausage that came out may have a different combination of fat and meat and protein and other ingredients that was not measurable. And that has an impact on the quality of each good coming through the system. And that can have a negative impact on the continued use by end users if they find that there's a lot of variability in the quality of their products. They've just recently, within the last few years, adopted a IoT solution for their processing, which they can measure and actually add in specific amounts of fat and ensure that all the flow rates, the temperatures are optimized to ensure that every single sausage is exactly the same. Of course, having standardization and processing is not a new idea. It's definitely one that's probably most prevalent across the major tier one food processors. But to think that even the big guys are still adopting these technologies is very telling that there's still definitely room for growth for technology providers in this space. And again, I mean, going back to what I stated before, the biggest challenge in food processing and in the agriculture nutrition space in general is the problem of an open system where there's a lot of leakages. There's a lot of hazards being produced. There's a lot of waste being produced. All of these occur at processing points and transition points in the processing. It could come from raw material, comes through logistics, it goes through the door, and each transfer, each transition from one node to the next is an opportunity for a hazard to be produced or waste to be produced. And that is waste and hazards drives cost, and it pushes down profitability for farmers. It constrains the profits of processors, and it makes consumers pay more for the food that's readily available had the system been more efficient. And what IoT does is, leveraging hardware, software, and a platform, a network and a platform, is able to ensure that it can identify and close those leaks before they occur, in many cases, or as they occur, in order to minimize waste and damage. And IoT is very much, it's not just a sensor. It's a combination of hardware, software, a platform that is optimized to do something, and also the tools and the equipment in the production process that will take the instructions of the system and to act appropriately, continuously, in the manner desired by the end user. And so we see applications throughout the entire value chain, whether it's in logistics, whether it's within the plant, outside the plant, and even in our own mobile apps. Capturing our purchase history, capturing our taste and preferences in that app. All of that information is being collated and has the potential to inform the entire value chain on what to grow, what to process, what to sell, and to whom. And that is the ultimate goal there. And with that IoT solution, there's no reason why all the industry participants in the value chain can participate or will benefit from that. So this chart looks at the $17 billion opportunity today, growing at 9.2% globally, and segments it by the levels of the value chain that we at Frost Sullivan evaluate. How we define the agriculture nutrition space. It starts with agriculture, crop production, livestock production, and the precision and smart technologies and applications there. Today, that is the biggest opportunity space among the steps, as you can see here, based on the fact that those are the tallest towers. About $5 billion today in global sales in terms of hardware, software, and these are, these include, and we'll get to this in a bit, includes everything from hydrospectral imaging that feeds, data analytical and decision-making software, sensors and sensor networks in the field, whether they're chemical-based, biological-based, or mechanical and digital-based, all feeding, the farmer's need for information. This information as well is used by upstream participants, including processors, so basic food production or beverage production. Complex food production is, the difference between basic and complex is, in basic processing, you're pretty much just processing raw material into more useful raw ingredients, such as taking soybeans and making protein and flour out of it. We're taking grain and making flour from it. Complex processing is taking those ingredients and making consumer-ready foods like bread, cake, and beverages and the like. We are seeing rapid adoption of IoT solutions at this level of the value chain for operations efficiency purposes and also for traceability. Traceability being the primary driver in that. And that is driven by grocers, grocery stores, food retailers who are demanding, in many cases, are the regulatory enforcement of clean food, traceable food, and ensured safety foods using technologies and IoT solutions that's backwards connected and interoperable with their value chain industry participants. Every industry is going to be different in terms of the amount of hardware, networking, and software that's required to solve the solution. And in process manufacturing, the need for hardware, especially when you have a lot of pumps and mixing, conveyor belts and tubes, vehicles, requires a lot of individual sensors and hardware that is able to capture and record and transmit information to the central processor. So hardware is, from our estimates, the largest segment of the market today at nearly $10 billion, $9.9 billion in 2017, likely surpassing $10 billion in 2018. It is the slowest growing segment, though, because hardware adoption is correlated to capital expenditure, and we expect that hardware adoption is definitely the first, the first things you would adopt in an IoT solution and for your given plant or for your given operation. And one thing I would like to note is many industry participants, what we found when we were conducting this research, sometimes they will adopt a brand new IoT-enabled, all the bells and whistles in one system, if you've got a greenfield opportunity, if you can start something from scratch. But in process manufacturing, it's quite difficult to just shut down an operation and then start anew, get a new systems integrator. So the adoption of IoT solutions is evolutionary. First you buy components, you buy your initial set of sensors for certain levels or certain points in your production process or in the value chain where there's the highest degree of need, most hazards, most waste, etc. And then over time, you interconnect those systems to your new equipment, and over time, you evolve into a more, tech-enabled operation. That takes time. So we expect that the adoption of hardware is definitely going to be first in that system, so you can get get that equipment in place, and then with new networking, new technologies, and new software capabilities, that will grow in the long run as well, which is why we see stronger growth in software and into the future to take the current base of capital and make it better operating with better software. Again, this $17 billion global IoT market is actually quite a drop in the bucket in the terms of the market that we are really addressing. The entire agriculture and nutrition value chain is $20 trillion in combined value generation per year globally. That is the combined revenue of all the key industry participants that's represented in these nodes in this value chain, from ag input suppliers, chemical suppliers, seed suppliers and traits, to the farmers and all the way to the consumer. The consumer sales, of course, retail sales. So there's a lot of, it's a big part of the economy, and there's a lot at stake, and a lot of it's at risk of breaches. And again, just to, I suppose, to just drill home the fact that this is a big, massive industry which has a potential, to have catastrophic consequences if there's a certain need that could be addressed with an IoT solution is left unmet. If I was to consolidate and summarize the three big drivers or growth factors of any market in the agriculture and nutrition value chain, it could be summarized into these three categories. And it's just because it's the nature of food. First, everybody eats. We have to know that. So population and population dynamics and population megatrends and how people are moving and using and how much money they are making, all ultimately determines, what we grow and what we produce, what we raise. So socioeconomic drivers and impacts has a major impact. That includes everything from taste and preferences to, rapid economic development, emerging regions. All of this has an impact on the shape and the operations and the efficiency of the system that we just looked at in the prior slide. And each of those nodes as well, has the same challenge as well. They have a need for resource efficiency. As I stated earlier, profits are small in agriculture and nutrition markets for the most part, the primary products. So there is a strong need for optimizing and maximizing yield and minimizing cost. And when you have an open system that is, with waste, with leakages, with the potential for hazards and potential liabilities, that's definitely not an efficient system. So there's always a need from the farmer to the retailer for adopting technologies that ensures and maximizes yield, and IoT delivers on that. And in this entire system, and what's making it more difficult to maintain its operations is changing tastes and preferences of the individual consumer. And specifically what I mean is the growing demand for healthier food. Of course, cleaner and healthier food is in the eye of the beholder, but typically it means products that are free of chemicals potentially in the final product, that's friendly to the environment, that is healthy to the consumer, and healthy to the environment as well, and morally and ethically produced as well. All of these requires checks and balances in the value chain, and requires a need for some system to be able to capture the state of this system continuously over time and space, which is what an IoT solution delivers. Focusing specifically more on food waste, I can't stress this enough. I always like to tell people that, we do produce enough food to feed everyone in the world. There's enough calories produced by farmers throughout the entire world to feed everyone if we had to. But the problem is it's a highly complex system, resulting in a lot of leakages. There's no, and it's to be expected. I mean, you have food is spoiled, you can't store it for very long, and when you're price driven, economy, you're going to save the most, independent of the possible externalities, negative externalities that may be produced in that system. Consequently, according to the Food and Agriculture Organization of the UN, about 30 to 40% of the food produced globally per year is wasted. 30 to 40%. That's a big number. And it's, it includes everything from, grain falling off the truck, or being, utilized, or just spoiled in warehouses, to even final consumers throwing away their last piece of bread or not eating their pizza crust. All of that is considered waste. Now, of course, changing consumers is much more difficult to do in their habits than it is for industry participants as well. And they have the added motivation to minimize waste because they know that directly impacts profitability. Now, where we see the first movers in the value chain, really, in terms of addressing the problem of food waste, that key challenge, trying to optimize and making sure you're trying to feed everyone, really starts at the farm, and even before the farm. There's a role for chemical suppliers, for seed and trait suppliers, and fertilizer producers, there's role for farmers, and also the agricultural equipment providers to help start that system in order to remove and minimize any waste that occurs on the farm as well. So in order to really enhance and optimize resource, we're seeing a lot of interesting new technologies in crop and seed technologies, so genetically modified seeds and traits, which requires digital technologies to able to simulate the genomes of a variety of plants and even animals to grow in certain conditions. So we're seeing a lot of that. Of course, there is growing demand for clean and organic crops, and the challenge there is, while you can sell those crops at a higher price to consumers willing to pay, typically the yield on that's much lower because farmers don't have the good best practices in developing these crops that are most in demand by consumers. So it takes time, it takes effort, and possibly a digital technology solution can definitely deliver some insights there from the consumer side. And of course, there's precision agriculture technologies that really drives, that we'll explore in more detail, but is really solely focused on ensuring that the farmers' resources are optimized and also yields are maximized. Just thinking more about precision agriculture technologies, we did find that there is a correlation between the perceived value of the crop and the probability or the likelihood that the farmer will adopt precision agriculture technologies in the field. Of course, there's a lot of variance across countries that can be controlled. For example, in the United States, maize and soybean are dominant crops and included in the non-cereal crop here. And those are highly industrialized, highly sophisticated growing operations typically, but not in 100% of the case. But there's, there's still room for there. But in general, the United States has pretty sophisticated crop production technologies and are leaders in the adoption of precision agriculture technologies such as sensors, hyperspectral imaging, variable rate technologies, et cetera, to really ensure that farmers in the United States are maximizing their potential profits. Japan's also a leader. Australia is also a leader, which isn't represented here on this chart, but also leaders in the adoption of precision agriculture technologies. But we do see that even in countries that, even controlling for that variance, if you're growing, or if you have orchards, if you're growing green vegetables, if you're growing fruits, and even livestock as well, the need for precision agriculture technologies is even greater. The per unit value of that shipment is much greater, and they have their own risks as well. There's a big difference between maize and soybean versus trying to ensure you can deliver your apples or your berries, which are typically much more sensitive, especially in the value chain as well. So ensuring that those products are cool, safe, clean, and shipped without bruising and impacting its quality in the value chain ensures that all the industry participants in the value chain are optimizing and maximizing their profitability. So we do have a dedicated report specifically on precision agriculture technologies, but we also address it in our most current report as well on the Internet of Things for Agriculture and Nutrition. And in this study, we have a very detailed summary of all the various technologies that are, considered a part of the precision agriculture technology ecosystem. And it includes the same things that we talked about before: software, hardware, the communication or networking, and others such as, these are more futuristic like cloud computing or machine-to-machine communication, artificial intelligence, which we're still very much early stages, pre-commercialized stages in most cases in a growing operation. But service requirements is also very important in precision agriculture ecosystem as well. And I think this really has to do with the fact that a lot of farmers, I'm sure they would admit it as well, may not have the technical background to use these systems right off or right away, and that's a barrier to adoption. They may not adopt these technologies because they don't know how to use it. However, what they will do, they do see the value of these technologies, and they will look to third-party service providers who are experts in the use and the installation of these systems, the monitoring of these systems, and even acting, by responding. What we call farm management service providers. They'll come on the farm and provide farmers, indirectly through a service model, the IoT solution most needed by the farmers. So clearly, where we see a more rapid adoption at this level of the value chain is among service providers who are serving a large field of farmers. Farmers, of course, will adopt technologies in the long run, like they've always done, but it will require continued effort from agriculture extension organizations within universities, precision agriculture companies, such as the equipment manufacturers like John Deere, Caterpillar, and others. And again, in our system, there's a lot of different examples. I think probably the most disruptive precision agriculture technologies that we've been tracking has been high throughput plant phenotyping. I kind of mentioned that before. Really leveraging laboratory to find those traits that are, and trying to do it as fast as possible in time for the next growing season, that adjust for drought, that adjust for lack of, low quality soil, low organic content in soil, and other, historical constraints on the yield of any plant. That's where we see a rapid adoption of interesting digital technologies that's going to be directly used on the farm, in the next growing season. Data analytical solutions is still disruptive at this time, but of course, I would say it's probably been in the market, available to farmers the longest. Fun fact, operations research developed by the military, U.S. military, leveraging math, linear algebra, was put into software and used in the military first, but then the first adopters outside of the military were farmers who recognized the benefits of using data analytics to hedge, to optimize their planting and project where demand will be and set prices accordingly. So very, very interesting application there. That was before other industry applications really took up operations research. Of course, there's other technologies that's been highly disruptive. GPS is, of course, it could remain unstated, but the impact of GPS on the ability to monitor fields from above to see where there's issues using hydrospectral or multispectral imaging has been transformational, especially in U.S. agriculture and really, global agriculture, really. In the future, we have seen drones. Drones are cheaper now, unmanned aerial vehicles. We're seeing much more rapid adoption. Regulations are still catching up to that, for that technology, for it to see rapid utilization and adoption. And these unmanned aerial vehicles, looking at the fields or sensing the, using hydrospectral imaging to get a sense of the temperature or the quality of the soil. But in the future, I don't think anyone on the call would be surprised that soon they will be the laborers picking the berries, picking the fruit, harvesting from above. We call them farm bots, an army of farm robots. So moving on, agriculture is not the only application for IoT, clearly. There's many, many different applications as well, especially within food processing. And quickly, some of the specific opportunities within food processing includes, the need for a harmonized food safety system. Over the last several decades, governments throughout the world have been trying to harmonize food safety standards. The European Union got it done. It's somewhat aligned to Japanese food safety regulations, some less aligned to the United States and Canada, which has its own system, but still, still interpretable. But the future of harmonized food safety information is likely not going to come from regulators. It's not going to come from government. It must come from industry. And the motivating factor will have to come from the fact that you're delivering value in terms of maximizing profits. That's the incentive for, in the past, harmonization was costly, because you're trying to comply to government regulations that may or may not take into account business operations. But I do feel that with IoT, you can achieve harmonization by having a common language throughout the entire value chain across countries, because all the industry participants have the same primary objective, maximizing value, which I think is kind of missing in harmonized food safety traceability regulations in past iterations. Of course, big data analytics is and I would say artificial intelligence is an extension of this, is clearly a big opportunity here in food processing and food manufacturing. In the case of Tyson, a long time they weren't able to control the temperature, the fat content, the protein content of any given unit of sausage they produced. With big data analytics, if their raw material, and it's primarily due to the fact because their raw materials comes in that highly varies. Sometimes, different livestock has different makeup. Some are fatter, some are lighter, some have different types of nutrition. Some were fed on corn versus animal feed. So that'll all have an impact on the nutrition content of the final product, as one example. But with big data analytics, they can control for that. You can move and adjust the operations, in a continuous fashion. So I think there's a great deal of opportunity there. Big area, one last point I would like to bring on this is rapid detection. In the past, food safety breaches were much more common. Actually, I don't have this in this document, but you can see a clear correlation between the adoption of these food safety and detection technologies with the rise, the number of instances of food safety breaches recorded by for example, the USDA or the FDA. You can see these types of positive correlations. And now companies from pharma, from IoT, or ICT applications as well, and especially sensor producers, chemical and biological sensor producers, understands that rapid detection methods is really a key need to really try to identify, essentially the breach before it breaks. By identifying foreign DNA in a batch of food, or using biosensors, or rapid technologies that can do quality assurance rapidly. And it's not just for safety either. It's also, in the case of Tyson, to ensure quality. It's not just safety breaches, but these rapid detection methods. If you could control and standardize quality before you see the issue, then you minimize the opportunity of producing a lot of wasted product, or suboptimal product that you may have to sell at a lower price. So the future. The future is kind of now, and you'll see. There's a lot of companies already doing this, but now that we've gone past processing, and we did talk about retail a bit, with the Amazon case. I think really where there's a big final frontier is consumer technologies in order to capture their taste and preferences, either consciously or even subconsciously, or based on their biological need that's sensed, with body sensors, wearables, smart sensors, to deliver a personalized solution to the consumer. Mass customization is what we call this trend, and this is just a version of mass customization that we're seeing across all industries. So personalized nutrition is generally used interchangeably with nutrigenomics at this time. These are two discrete topics, but you do tend to hear folks kind of interchange. But it is the study of how genes and nutrition interacts. That's and the idea is that, well, if we understand the genes and we can monitor the biological processes of individual people, then this information can be compiled and sent to, perhaps a fulfillment center that can, or a food company or another organization that can make a meal kit or make a food product or deliver food products that will get you back to where you need to be, your benchmark. For example, suppose that this individual here has high cholesterol, and they ate a lot of meat and dairy over the last month, and their LDL cholesterol levels is rocketed. It changed significantly in the last month. This information could be sensed, with a wearable technologies we already have, but this information could be sent directly to an organization like, Amazon or any food company or and the like. They'll see that and they will ship apples to you right away to try to get that fiber and to ship foods high in phytosterols, send maybe even phytosterol food supplements. If they're using a dietary supplement solution to help control for your nutritional needs, again, that could be delivered in one day, and then the user can use it immediately to try to get back on course without the user even having to think about it. They don't need to test, that they need LDL. They don't need to go to the doctor to get it verified. They don't need a prescription for whatever, but they'll just be automatically in the system and using a controlled personalized nutrition, subscription or regimen. They will have optimal food when they need it. A lot of industry participants are clearly already doing this. We see big companies like Campbell Foods and Nestle and Samsung and BASF, among others, who are already looking at these the potential opportunities of partnering with technology companies and leveraging their core capabilities in order to ensure that they are first movers in the personalized nutrition space. Clearly, companies that are technology enabled already and that have a wide physical and digital network, companies like Amazon or others, will be, could move faster in this. But what they're missing is that institutional knowledge of, food science, and genetics and genetic science, and really trying to ensure, and really that understanding of how can these food companies deliver food products that are most needed by the end users. It's going to be very interesting development over the next several years. We expect to see some really interesting models, new business models in the marketplace in the coming years. After in the next 5 to 10 years, some will be subscription based, some will be similar to what I don't know. Some of you guys on the call may have a Kroger account where you just click list it, and then you go pick up your groceries, or they deliver your groceries. But taking the consumer choice, and I think the big barrier is definitely going to be consumers wanting to let their decision being made by someone else based on their biology as opposed to based on their heart and mind. So that's going to be an interesting barrier. Some of the key challenges, again, just to reiterate what we found is, personalized nutrition currently means, different things to different people. So I think what we need now is official definition and segmentation. Personalized nutrition solutions are provided by service providers who has the vision of putting the food and the genetics and the monitors and the technology together into a optimal platform. But I do think that ingredient manufacturers, or food producers who have the products that really delivers the true value of what the consumers want will become the dominant market players in this space in the long run. I think there's also a requirement for, clear regulations and direction from regulators. It remains to be seen how personalized nutrition market will evolve with regards to regulation. There could be a need for some food producers, novel ingredient producers in Europe or elsewhere throughout the world, to impact, harmonization. Maybe this is going back to the story of harmonization. Maybe it's not a government thing, but, must come from industry. And then, of course, the cost versus benefits analysis. This is a premium idea, a premium product in this case. And an analog I'm thinking of is like meal kits, such as companies like Blue Apron or among others. Their target market is definitely those who can afford to, pay for these meal kits in exchange for convenience and time savings. Here, clearly, the target is going to be not only time and convenience savings, but also those with the highest concern for their own personal health and the health of their families. Those will be the first mover adopters of personalized nutrition. So finally, some key takeaways from our research in the Internet of Things for agriculture nutrition market. There's a lot of great opportunities in this space, a $20 trillion market. There's, at the final end market, 17 billion technology growing at 9.2%, to reiterate. So it's a substantial market space and has a great potential for many different types of industry participants, software suppliers, hardware suppliers, and food producers to be first movers in this space and really carry it to maturity. There are challenges in the way. I think, again, I noted this several times, that harmonization is really critical here to ensure that these systems are truly interoperable, maximized potential for all the systems. And I think, with current events, current socioeconomic events, political events, the trust that regulators will get it done for us maybe that shouldn't be as high as it used to be. But I do think that the need is still there. And I think there's an incentive for the industry to adopt these types of technologies because they will achieve resource optimization in the long run with the adoption, and that should convert to profitability. And then finally, I think that I would say the next set of technologies, and I didn't really talk about much today, but we cover in our report and other research we have at Frost & Sullivan, is the role of video and artificial intelligence technologies in food processing, logistics, and even retail. We see prototypes, the Amazon Go convenience stores. We see prototypes in other industries as well. Using this combination of, it's basically a artificial head. It has the eyes, it has the nose, it has the brain, and has the ears, and it processes sounds and video and all other all other environmental drivers to help give a recommendation on a continuous basis to the machine, and it learns. It doesn't forget. So that will be something of interest in the industry. I think adoption of these technologies will be rather evolutionary, as I stated earlier in our discussion, but it will be very much a interesting area to watch out for. So with that, I appreciate everyone's time today. I know I kind of went. We have about 5 minutes. So I'll turn it back over to Anna for any comments or questions.
Thank you, Christopher. Yes, I just kind of wanted to go over some quick next steps before we start a question and answer session. So if you'd like more information about joining our Leadership Council, please reach out to us. You can contact us at 1-877-463-7678 or send us an email to myfrost@frost.com. Also, your feedback is very important to us. So under the Rate This button, please provide any feedback, comments, or suggestions. And also you can follow us on any of our social media sites here, LinkedIn, Twitter, to keep up to date on upcoming webinars and our growth, innovation, and leadership events. So moving on to the questions here, Chris, I don't have any questions at this time from our audience. Is there any final thoughts you'd like to add before we close the session out? We have about 4 minutes.
Well, we covered a lot of different topics today, and clearly we're open for feedback and comments and questions after today's call. I do want to note that we do have a pretty extensive library of research that specifically looks at different levels of the value chain. The report that we alluded to today is pretty extensive across the entire value chain to give that inclusive, holistic picture of the opportunity space for the Internet of Things in food processing, agriculture, and retail. We're more than happy to I'm more than happy to get on a call or talk to anyone and address any specific questions offline as well. We have, I guess, one last point I guess I would also make is, I don't think we're really done with, the IoT. I mean, I know we're in the growth stage, but I do feel that there will be a significant disruption in the food and beverage value chain in the future, whether it's politically motivated, economically, social, that's going to require a technical solution, indirectly or directly. And I think that there's still some unmet needs there that could be addressed by key industry participants. Because, just looking at the opportunity, looking at what's out there and the possible breaches and the possible issues that key industry participants currently face, wouldn't be unheard of to have a serious issue that could have been addressed before. And also, again, I stress again that personalized nutrition, I think, is really a hot area of growth. It's very much untapped, but their need for mass customization across all industries, not just food and beverage, is real. Consumers want goods and services that meet their exact needs. And Gen Z and millennials and younger generations will come to expect that. So I think that, those companies that are making moves today will likely be the innovators of tomorrow to address those needs. So with that, I appreciate everyone's time today. I look forward to any feedback or thoughts. And of course, this recording will be available to all participants or registrants. So thank you, everyone.
Thank you for everything here, Chris. And this concludes today's presentation. So as Chris mentioned, our contact details are on your screen at this time. And we want to thank you again for your time. Enjoy the rest of your day.